So first we're going to identify the components. We have here the 120 volts emergency switch. On this side is the black wire, that's the white wire, neutral. And then we have the combination fan and limit switch. This side is the limits and this side is the fan. Normally closed, normally open, combined. And we have the gas valve, pilot safety, indoor fan motor or IFM. The fan relay, it is a relay, but because it's going to be operating our indoor fan, so we're going to call it a fan relay here. Fan relay. We have a capacitor. This is 5 MFD, 5 microfarad capacitor. We have the transformer. This is a step-down transformer, stepping down from 120 volts to 24 volts. And we have our thermostat. We have the RC, which is 24 volt cooling, and RH, which is 24 volt heating. The W is for heating, G is for fan relay, and Y is for the cooling contactor. So now let's wire this component, and then we can talk about in detail how the components work. So coming from here, we're going to get our main power from here, 120 volts. It's going to come down, we're going to split. Come down and feed in power to the common side of the fan relay. This fan relay down here is 24 volts. That's the core side, that we call that the load. And this is a normally closed, normally open. So once I send power to the common, there's power running down all the way straight to the normally closed contact, and the normally open stays open. So what we're going to have to do, we're going to get power from the normally open, which is going to be black wire, coming down to the cooling wire, the black wire, which is high speed for cooling. And we're going to get power from the normally closed, which is power coming out, and we're going to feed power in to the fan center on the combination fan and limit switch. Now we have power coming in here, but there's no power going through because this is normally open. So what we're going to have to do, we're going to have to get power from the top of the normally open fan switch on the fan center and bring it down to the low speed on the indoor fan motor, which is this red here. So we're going to use a red wire. Come down, red. Low speed for heating. We have the high speed for cooling. But if you look at this right now, the high speed, which is black wire, is coming straight from the fan relay, but it's coming from the normally open side. The red wire, which is the low speed, is coming from the fan center, also from the normally open side. So now we're going to have to get power from here, the main power, and send this power down to the fan center. Now the limit side has power. But what I'm going to have to do here, just to be safe, we're going to have to break this contact here, which is normally a bridge, a little brass tab in between. That's broken. So I got my power coming straight from the switch, feeding the normally closed side of the fan center, which is the limit switch. From the limits, I'm going to send power onto my transformer 120 volts, which is going to be the black wire right here. I got black wire coming into the transformer. This transformer is not working yet because you need to have a neutral to have a complete polarity. So right now that's not working. I'm going to be using blue for white. So now what do I have to do? Let me complete this circuit coming in with 120 volts. I'm going to get a neutral wire coming from here, which is going to be white. And that's going to jump out. Transformer has 120 volt right now going to the transformer. Okay? So since we have 120 volt going to the transformer, and we have the fan here, the indoor fan, it's almost done. We're going to also complete the polarity by bringing in the neutral to the fan white. Now this fan completely has 120 volt wiring done. All we have to do now is to complete the capacitor, which is 5 microfarad, to run this fan. So I'm going to have to get a brown wire from here onto my capacitor, another brown wire from here to the capacitor. Now this blower is actually ready. Once this relay contact energizes, it will close this normally open side and open the normally closed side, and then the fan will come on high speed for cooling. Now for heating though, this relay is not going to do anything with the fan. What happens once the burner comes on, the burner is going to burn and create a temperature of about 150 degrees Fahrenheit inside here. I'm going to use a red marker here. 150 degrees Fahrenheit in the fan center. Now once that 150 degrees is activated here, it will energize and closes that fan side. Now we're going to have 120 volts going to the fan, and the fan is going to come on in the heating cycle. So let's go ahead and close this, assuming we have heat coming in. Once the fan blows, the fan is going to blow and cool that fan center down. After the thermostat has reached its temperature, it's going to cool it off to 100 degrees Fahrenheit. For this older unit at 100 degrees Fahrenheit, now this is going to de-energize and open the circuit again, and the fan is going to go off. The limit side is going to stay closed, hopefully if everything is good. If that limit side breaks in a closed position, what happens? It will not turn the unit off. The burner will keep burning. Thermostat temperature, you may have set it to 77 degrees, and you come into the apartment or house, the temperature is 105 degrees because the limit is broken in a closed position. It's not cutting the gas off because the transformer is still sending 24 volt to the gas valve. Let's see how this 24 volt goes to the gas valve. So we're going to have to power this thermostat. Is called a 5-wire thermostat. 5-wire means the thermostat have 5 terminals. Anytime you have a 5-wire 24 volt thermostat, this thermostat is called an isolating thermostat. That means you can isolate the heating from the cooling or the cooling from the heating. So we're going to send power straight. I jumped the RH and RC, which is the 24 volt heating and cooling. I put them together, I send 24 volts to them. So now what we have to do, we have to get the heating circuit, which is W, coming down. If you have any safeties in this feature here, when the power comes from W, which is a heating circuit from the thermostat, it has to go through all the safeties before it gets to the gas valve and go back to come on the transformer to complete the circuit. So here we have a pilot safety, which is the only safety in this particular circuit here. So we're going to send power into the pilot safety. The pilot safety is having power coming in. The power is going to get out of the pilot safety into the gas valve. Now we have sent power to the gas valve. The power is going to get out from the gas valve. This power should be going to the transformer common. But why I'm going to hold it here for a minute is I'm going to need 24 volts here also common going to the transformer common. So in that case, I can jump them together, pigtail them, and send them back to the transformer. So the G, which is the fan relay from here, this G is going to come down, and it will get into the fan relay 24 volts. Gets into the fan relay 24 volts. And then from the fan relay 24 volts is going to get out from here. Now I can pigtail these two together and take one wire, bring it over to the transformer common. So pretty much the heating circuit is done. Now once you call for heating, what happens on your thermostat? You have RC, RH, you have W, I'm going to use blue for white, you have G for green, I'm going to ignore yellow, that's for cooling contact, so that will be on this part of the circuit. So once you call for heating, what happens? This contact here, the RH, which is 24 volts heating, and the W will close, and you hear a click in your thermostat. Once you hear that click, this is going to close. So what happens? This and this, they will close and